Hello everyone, my name is Eric Jones, better known as the Turf Teacher. Welcome to the course entitled Applying the Correct Amount. This information comes directly from your North Carolina Pesticide Applicator Certification Core Manuals. And let's get started with this lecture by looking at some objectives. We're going to understand what calibration of equipment is. Why do we do it? How often do we do it? And why is it important? Calculate the application area size, guys. We need to know how big the property is, or the size of the field is when we're applying pesticides. And that's going to be determined by length times width, guys. We need to know some basic math here. Then we're going to determine the application rate and where we find that information. We're going to determine the amount of pesticide carrier and the concentrate that's going to be used in our pesticide application. And then understand the nozzles, the speed and the pressure, and how that can affect the calibration of your equipment. So some pretty important objectives there, guys. Starting off with understanding calibration and how we're going to get started. We're going to determine how much to apply. And where we're going to find that information, guys, we're going to find it in the directions for use. You've already seen the lecture entitled Pesticide Labeling, so you should be very familiar with that pesticide label. And we're going to find our application rates in the directions for use. And what if it states a range? Let's say it says 3 to 4 ounces per gallon of pesticide to be put in 1 water of gallon. Well, guys, you want to use the lower amount to achieve your desired effect. So we want to go with 3. But what if 3 doesn't work? You know, there's been guys out there in the field a couple weeks using this new pesticide, and the label states 3 to 4, and you've used 3 ounces, and you know you're going to use 3 ounces because you read the label and you follow it to the T because the label is the law. But you speak with a consultant or an industry organization, the Turfgrass Council, or a landscape organization, or a cooperative extension agent. Or you've done some research on the computer at a university's website, and you've talked to the pesticide dealer. Your pesticide dealers, guys, are some of the most knowledgeable people that I know. They know the product that they're selling. They're putting it out there in other landscape companies. And that 3 to 4 ounces per gallon, when you purchase it, and they're telling you, say, hey, Eric, we sold some to a guy last week, and you know, they used it on one property at the lower rate, 3 ounces per gallon. It burned the weeds back a little bit, but it didn't do the trick. So on the next property, they bumped it up to 3.5 ounces per gallon, and they're getting great results. Guys, we're colleagues, not competitors. Pass this information along, and that helps everybody out. We're stewards of the land, guys. We're not out there to be cutthroats. If you figure that out, pass it along to your dealer, pass it along to your extension agent so they can pass this information out to everybody else. But guys, always check with your pesticide dealer. They've got that extra information called labeling that they can give to you. They've got all kinds of product information that may be a little harder to read on that fine print on the label, but you still have to read that label. But they could give you maybe a printed out copy that's coming from the internet. Because a lot of times I've seen labels in little bitty booklets that's attached and glued to the container. Well, print off a PDF from the internet and get that from your pesticide dealer, or print it off from your computer. But guys, this group of people right here has a lot of information about that product. Application rates can be stated on the label in how much per area, or how much pesticide per mixture, or even in a percentage. Adjuvants can be added to improve the effectiveness or the safety, and are often added to pesticide mixtures. We've added them all the time, and we saw that in the last lecture when it comes to pesticide formulation. But you can see things stated like 5 gallons per acre, 5 pints active ingredient per acre, or even 5 tablespoons per gallon. And occasionally the application rate is expressed in terms of percentage of the final dilution. For example, 0.5% by volume, or 1% by weight. Guys, yeah, and a lot of the stuff that we use, we're not going to have that. We're going to be doing a lot more like 5 tablespoons per gallon, or better yet, 3 to 4 ounces per gallon. That's my favorite type of chemical, because, you know, guys, look at it. What we're putting out pre-emergent in the spring on our turf grass. That's going to be in a rotary spreader. Yes, some of you guys may do dual, have either dual tanks or mix it all together. But I'm going to put out my pre-emergent fertilize. So I'm going to calibrate my spreader. I'm going to do that twice. I'm going to go back and put out more fertilizer that doesn't actually have a pesticide attached to it. And if I'm using a broadleaf herbicide for clover and broadleaf weeds, I'm going to keep a backpack sprayer on the trunk with my fertilizer spreader, and then I'm going to have a small truck mounted sprayer. I don't like the big ones, I like the smaller ones. And if I've got a yard that's got a few weeds in it here and there, I'm going to get the backpack sprayer off, guys. And so we're not using too many chemicals. You know, we're not in agriculture. We're in the green industry. We're lawn care technicians. We're landscapers. We're spraying, you know, Roundup or Finale or something in the shrub beds to take care of the weeds, and then we're spraying a selective herbicide on the turf grass to get rid of broadleaf and grassy weeds. So there's not a huge range of pesticides that we're using. So, you know, we're probably going to be pushing it out ounces per gallon, or you know, using a rotary fertilizer spreader. Well, let's say you need to calibrate your backpack or your truck sprayer. You're going to calibrate it with water only. You're going to find a parking lot, either gravel or pavement. I'll prefer pavement because it's a lot easier to see the uniformity, but you're going to calibrate it using that area. And there's a YouTube in this unit on calibrating a backpack sprayer using the 1/128 method. Some pesticides are ready to use and are applied until they create runoff, like aerosols, baits, foggers, dusters, or collars. Well, guys, runoff, we're not talking about running down the street into the storm drain. We're talking about wetting the foliage and a little bit dripping off. That means you've covered it to take care of, to achieve your desired effectiveness. Other ready to use need to be loaded in an applicator that requires calibration, including most granular dust and some even in liquid form. But again, our rotary fertilizer spreader. And in Unit 1, there is a YouTube on that as well. Some concentrates don't need to be applied with calibrated equipment. They're just diluted, loaded, and sprayed enough to cover thoroughly, or applied to the point of runoff. Again, wet in the foliage, let it run. Most concentrates have to be diluted and applied with calibrated equipment. Guys, we're buying concentrates every day, whether it's you know, Roundup for the shrub beds, or you know, Speed Zone or something like that we're using for broadleaf in our tall fescue turf. So we're going to buy the concentrate, and we're going to calibrate our equipment, and we're going to calibrate our equipment every single morning. Your lawn care technicians, the first thing they need to do when they get to your shop is calibrate that equipment. You got other guys loading their equipment and stuff. They need to take care of their stuff. And better yet, guys, they need to come home with empty tanks. They don't need to leave that pesticide mixture overnight in the sprayer. The sprayer needs to be empty. And guys, if you're calculating your areas of your lawns to the T, and you know how much you're going to spray that day, you should be able to know how much you're going to need to fill up, or if you're going to have to fill up once or twice to get through the day based on the square footage that you're applying that day. You got to keep good records of this and know how much square foot or square footage that you're treating a day. And so you can come home with an empty tank, clean it, and then the next morning recalibrate it before you go back out. Trust me, it's worth it. Now, you'll see why here. Calibration is the process of measuring and adjusting the amount of pesticide your equipment applies or delivers to a specific point. It's the area that you want to apply. The benefits of calibrating your equipment, guys, include safety, efficiency, and cost saving. Applying more or less than necessary is a waste of money. But Eric, I'm applying less. Why is that a waste of money? Because you didn't achieve your desired effect. You're going to have to go back and spray again because your client ain't happy. Eric, the weeds, they look like they're dying, but they didn't die. And then all of a sudden they perk back up. Well, you used 2 ounces per gallon instead of the range of 3 to 4, or you didn't calibrate your equipment. Guys, it drives me crazy. You have to take care of your gear. Take care of your gear's going to take care of you. Treat it right, respect it, and it's going to do you favor upon favor, guys. I hate seeing people lose money because they didn't calibrate their equipment right and they're putting out way more pesticide. And again, guys, that's against the law. The label is the law. And if you're applying more pesticide than is needed, you could be in trouble. You could be in some serious trouble if it came down to it and, you know, the state inspectors found out that you were applying more. Calibration rate is affected by the travel speed, whether walking, pushing it, or riding it. You need to measure it. You need to know how fast it's going. You need to know how fast you're walking. You need to do a stride test and see how long it takes you to get to point A and point B in so many seconds. It's affected by the particle or droplet size and the pressure or drop mechanism of the application equipment. First, make a trial run using only water. Let's talk about a backpack again. Measure how much time it takes to physically go over the area, then measure how much water is sprayed for that amount of time. Use the measure of water to determine the amount of pesticide use. Simple stuff, guys. The 1/128th method, that's the way to do it. On page 170, uniform release. If the application equipment you will be using has more than one nozzle or hopper, part of the calibration process is to measure the output from each source to be sure that they are all releasing the correct amount of pesticide. This takes a little more time, guys, a little more time. Note whether the pesticide output from one or more nozzles, group of nozzles, or hoppers is 10% more or less than the desired amount. Check for clogging or other obstructions in the openings that were distributing less. Look for leaks or worn parts in the openings that are distributing more. If the problem cannot be corrected, replace the nozzle or hopper. You've got to do that, guys, and you'll go through a ton of nozzles. That's just the way it is. It's the part of doing business. And there's two methods that you can do this with. Method one, you can operate equipment at a standstill for X amount of time and measure the output in a container. Or attach the containers to each nozzle or hopper and run the equipment over the intended area. Then measure the outputs in the containers. A lot of work, but it's necessary. Your test application, do an accurate measurement of the amount in the tank. Operate the equipment over the intended area at a constant speed. You can't hit the gas pedal, guys. You got to keep it steady. Measure the amount needed to refill the tank back to the pre-application level. And again, this should be done only with water. The only time you're going to calibrate with your product is in a fertilizer spreader, and that needs to be done on pavement, particularly a blacktop or asphalt, because you can see it. The fertilizer is going to be white or yellow, so it's going to really stand out, because you need to sweep it up and use it later. You can't leave it on the ground. But that's the only way to calibrate your fertilizer spreader, is by using the product. But to figure your application rate, it is the amount dispersed divided by the distance covered is going to give you your application rate. With small sites and you're using small equipment, you can scale down and use a small test area. But if you're doing a large farm, large fields, you're going to be using large equipment, so you need to use a larger site and a larger amount of water to calibrate your equipment. That's just the way it is. All right, now we got some math here. The first chart here, both of these come from the National Pesticide Applicator Certification Core Manual. It's a good manual. North Carolina adopted theirs. Adopted their own. Very similar, though. The chapters are a little different in sequential order. But these charts come from the National Core. Rectangular areas, guys, you need to know length times width. The typical square yard, the square lot that we're going to work at. This one's 120 feet by 1320. We're going to multiply those two together, and we're going to get 158,400 square feet. Divide by 43,560. Why are we dividing by 43,560? Because that is an acre. Guys, burn 43,560 square feet in your brain. You need to know that number. That is how many square feet is in an acre. Now, we multiply that, we got the 158,400 divided by the 43,500, it gives us 3.6 acres. So that's a pretty good size lot. You're working for a higher end client there, a client with some money. And then look at a triangular area. And some of these lots that we go into the neighborhoods, yes, they're wider in the front or they're wider in the back based on, where they're located in the neighborhood. I've seen some triangular lots. That's just the way it is. Best way to see that is take your drone and fly over some of these neighborhoods, and when you see the fences, the backyard fences of the people, you'll see them taper to the back like that. But the area of a triangle, base times height divided by 2. And so here we've got a base of 150 feet and we've got a height of 320 feet. So we're going to say 325 feet times 150 divided by 2 gives us 24,375 square feet. Divide by the 43,560 and we've got 0.6 acres. We've got just a little over half an acre here, guys. That is a typical yard that we take care of, So we're looking at almost 25,000 square feet. A typical yard. Good stuff here, guys. A circular area. Let's say you've got a client with a circular turf grass patch in the back, or in a roundabout, a drop-off in a commercial site. People pull up to the front. It's all turf grass in the front island. Well, it's got a diameter of 90 feet. So that's going to tell us that we have a radius of 45 feet because the radius is half the diameter. And we know the area of a circle is pi r squared. Well, pi is a constant of 3.14. And we know that the radius is 45, so we're going to say 45 times 45 times 3.14 is going to give us 6,358.5 square feet. Divide that by the 43,560, and guys, we got 0.15 acres. Hey, the perfect typical drop-off area on a commercial site. Now, let's look at this problem. Calculating the application rate. You determine from a calibration test that your boom sprayer delivered 10 gallons of water over a 1/4 acre test area. You applied a pesticide product. You need to apply a pesticide product to a 10-acre field. Well, we know that 43,560 square feet is in an acre. The pesticide label recommends that 4 ounces of liquid product be added to give a desired finish of spray mixture of 1 gallon. There are 128 fluid ounces in 1 gallon. How much spray volume and how much product are needed? This is a 3-step process, guys, for this particular problem. Step 1, how much spray mixture is needed for the 10-acre application area? Always use information from the calibration test. In this example, 10 gallons of water was used over 0.25 acre calibration area. So 10 acres over 0.25 acres equals Y gallons divided by 10 acres, cross multiply. So we got Y equals 10 gallons times 10 acres divided by 1/4 of an acre equals 400 gallons of spray mixture. Step 2, how much pesticide product is needed to make up 400 gallons of spray mixture? Use the label rate of 4 ounces of product per gallon spray. 400 gallons of spray mixture times 4 ounces of liquid pesticide product per gallon equals 1,600 ounces of product needed. So in step 3, how many gallons do we need? 1,600 ounces of product divided by 128 ounces per gallon equals 12.5 gallons of product. Now, typically most of our pesticides that we purchase are in a 2.5 gallon jug. So we would need 5 2.5 gallons of product to dump into this tank mixture. So cool math here, guys. You're going to love the landscape pesticide calculations lecture and that worksheet that goes along with it. Good stuff. So our final result for this product, to treat the 10 acres, you need a total fine spray mix of 400 gallons that includes 12.5 gallons of concentrated product. Check for misapplication. Keep an eye on the amount you are actually applying for the load you calculated. If something is off, stop and check your calculation and your equipment. You can catch and correct any errors before it's too late. Guys, calibrate your stuff. Use water. Spend the necessary 30 minutes each morning to calibrate your bigger stuff. It's not even going to take you that long for smaller equipment. Do it. Save money. Be the steward of the land and do the right thing. Doing the right thing is always the right thing. And guys, this concludes Chapter 12 in your core manual. My name's Eric Jones, the turf teacher. I'll see you in the next lecture.